Peroxisomes. Name of peroxisome comes from the chemical peroxide. Peroxide, yes, we're talking about the same stuff that you clean your cups with, right? Hydrogen peroxide. And the reason that we call them peroxisomes is because in the chemical process of breaking down toxins, it produces hydrogen peroxide. So that's where its name comes from. Peroxisomes deal more with the breakdown of toxins and bad things in the cell, much like we also said the smoothie R does as well. But it's kind of like the liver of your cell. If we're going to compare it to an actual organ, it's the one that's going to go ahead and detox. That's your liver's job, right? It's the one that processes any chemicals, any drugs, any alcohol. Your liver's job is to break it down, which is why it's possible to overdose. Because if you take in more than your liver can break down, then you're flooded with all these toxins. Same thing happens in a cell. Any cell that encounters more than a peroxisome can handle, it's going to cause the cell to die. It can no longer perform its functions. A food vacuole is kind of almost exactly what it sounds like. It's like a pantry inside of the cell. It stores food. It's not like it stores muffins and granola bars and bananas, but rather it stores cellular food. So anything that the cell would be using. In that instance, remember we're talking about our carbohydrates. It's going to store sucrose, glucose, things that the cell is going to process.
I have a question about the peroxisome.
Mm-hmm.
Would it kind of like heal if it produces like peroxide?
Peroxide actually, the reason that you pour it on wounds is because it acts as a disinfectant, right? What it's actually doing is killing bacteria. So peroxide itself degrades material, which is how it assists in breaking things down.
For peroxisome, what does it produce?
Peroxide. And that promotes a very acidic environment. Very acidic environments promote things to degrade and break down. So it's a happy little circle. Lysosomes also have to do with breaking things down in the cell. And for some reason, teachers usually call it the cell's cleanup crew and then say Lysol. Think of Lysol. But it's not just like when I think of Lysol, I think of cleaning up messes that are bad. The lysosome's actually going to take things that are good and break them down. It makes them usable. It's essentially digesting. And when it does this digestion, it does so in a very acidic environment. Think of this like the stomach of your cell. Your stomach is full of acid. The reason that it's full of stomach acid is because that promotes the decomposition of any food that you consume. Now, granted, by the time it reaches your stomach, we don't call it food anymore. But you know what we call it? Super gross. Bolus. Bolus is actually what happens when you take food product and you chew it. It's the name that we refer to as scientists for food mixed with saliva. Because your saliva has all kinds of enzymes that break things down and starts the digestion process. That's what lysosomes are full of. Enzymes that are going to break things down and start the digestive process. So despite the fact a lot of teachers will say cleanup crew like Lysol, also consider it kind of like a stomach. Does some digestion. The last two I forgot to tell you, we entered into the land of animal only. As soon as we did food vacuole and lysosome, we started covering things that occur only in animal cells. The next two we're going to do together. And the reason that we do them together is because a centrosome is a complex of centrioles. Two of them, to be precise, that always occur at right angles to each other. Their job in the cell is to organize cell division. Some of you, from your pasts, I will say the word mitosis. that's where our friends, the centrioles, play a pretty big and important role. In diagrams of the cell, they usually look like, there are a few things we call them. I think they look like the little Twizzler pull-in peels. And the reason I say that is because they're made of a bundle of microtubules that are parallel to each other. Just like your Twizzler pull-in peel, right? It's like a bundle that all runs parallel. You could also think of it as a bundle of straws. Some people think it looks like a star. What kind of star that is? More like an asterisk if you look at it, truthfully. And some people say a churro. It looks like a churro. That's the shape it has. So a centriole is one of those things. One bundle or one churro or one Twizzler pull-in peel. The centrosome is the two of them that occur at a right angle. That's the difference. Yep.
So what does a centriole do?
Organizes cell division.
And
Cell division is mitosis, so it organizes mitosis.
so centrosome, so they can do the same stuff, except that,
Oh, well, they do the same thing because the centrosome is made of centrioles.
oh,
It's just the centrosome is two centrioles together. They're always at right angles to each other.
So what the microtubules do?
So the reason that they're made of microtubules is because those microtubules make a particular fiber that helps during mitosis to migrate chromosomes to opposite sides of the cell. So that's why they're made of separate little pieces. Those are animal only, by the way, not plants. Animal only, not plants. Then, now that we're done with those two, plant only. Moved on to plant only. Things that are found only in plants start with is a central vacuole. If you were to look inside of a plant cell, it would look predominantly empty. It would look like it has one big empty bubble. And it's not actually empty. That central vacuole stores water and dissolved ions, potassium ion, sodium ion. So those are stored in the central vacuole, water and dissolved ions. I have such a short attention span. I looked at your shoes and I was like, I don't like his shoes. There it goes. You know what happens to a central vacuole when it empties. You know what happens to the plant. It's the same thing that happens to a plant when you forget to water it. What happens? Before it dies, what's it do? It wilts, right? But if you didn't wait too long, you can save it. If you water it, what happens? It
Grow.
unwilts, for lack of, I don't know, what is the opposite of wilting? Unwilts. It refluffs. You've seen that process before. You've seen a plant wilt. You know it's wilted because you look at it and you're like, that plant needs water. It's true. The result of water rushing into a central vacuole, you may also be a problem now. What's interesting is how can I move you?
yeah, Mark's
Yep. Don't worry, I did see him actually gesture you first. I warned. You're all day, kids. So, that act of water rushing in and providing a cell structure is called turgor. And it's unique to plants. Turgor. Turgor. And that's what happens when the central vacuole and plant cell are full of water. It gives it a nice rigid structure.
Wait, what does a turgor do?
Gives the plant structure. Think of it this way. What happens when you let all of the water out of a waterbed? It deflates. Like, not waterbed-like anymore. Add the water back in, it resumes the shape of a waterbed.
What was the it called?
Turgor. Turgor.
So you can refill like the central vacuole? Is it just the central vacuole or will it
Just the central vacuole that's going to fill with water like that. Just the central vacuole will fill with water.
Where's the water fill?
It gets used in all of the cellular processes. So when we look at photosynthesis, it's going to use it.
And then it gets water from the rest of the body.
So that's what happens there. Next one up there is chloroplasts. Gosh, please don't make me tell you what chloroplasts do. Do I have to tell you guys?
Yes.
You can tell me. What happens in chloroplasts?
Photosynthesis.
Woohoo! There we go. Photosynthesis, and it gives the plant its nice green color because of the pigment. Chlorophyll. Noah? Chlorophyll? Because of the pigment chlorophyll that exists in chloroplasts. Remember last chapter we had the endosymbiont hypothesis where we said that we believe that mitochondria were once free living things because they have subcompartments inside the mitochondria? Same story for chloroplasts. There are subcompartments within chloroplasts called the thylakoid and the grana. They're small and they're stacked. And they're stacked up. They look like, you guys don't know what that is. If I took like a roll of Smarties and stood it up on its end, they're stacked up inside of chloroplasts. And that's the actual physical location that photosynthesis occurs. So that's what those parts are. They're subcompartments of a subcompartment. Because isn't the chloroplast just a subcompartment? And there's an even smaller compartment within the compartment of the thylakoid and the grana. Thylakoid and grana. I just want to make sure everybody spells those words because they're kind of funny.
Is that the end of the grana?
Yep. Plasmodesmata, they're just pores within cell walls that allow communication from one to another, from one cell to another. It allows the passage of any materials. Allows passage of any materials. The cell's wall, you already know, is made of cellulose in plants. The best descriptor of why it's so important is probably pointed out by pointing out the cinder block wall behind you. Because not all of us are excellent and knowledgeable about construction. So I will point out something that hopefully is fairly obvious once you think about it. The bottom cinder blocks, it's really important that they are perfect in structure, right? They bear the load of every other cinder block on top of it. So next time you hear that bowling ball hit the cinder block from physics next door, hope that it doesn't do any damage to those bottom cinder blocks. Why? Yeah, if those break, there's a point of weakness in my structure, everything else comes down around it. But up there in that spot next to that vent, am I worried about that one that looks like it could very well just tumble out of the wall at any given point in time? No. Why not?
Because if it falls out, then it won't affect it.
Yeah, it's that load bearing, right? So, I mean, Alexander might not appreciate it. But other than that, the wall's still intact. Are you nervous now? Don't worry, it's not gonna fall out. I've poked it a few times. Now you're like, oh, that just compromised the structure more. No, I promise, it's not going anywhere. So we look at it and we recognize that the structure on the bottom has to be very, very firm and rigid to allow other bricks to stack on top of it. Same thing happens inside of cells. cells have to have a firm and rigid structure to allow them to be load-bearing for all of the other cells on top of it. Plants accomplish this by the use of a cell wall. The cell wall allows that central vacuole to fill all the way up with water, and when it's full, it bears the load of the entire plant on top of it. Now, some plants can get very, 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 very big. Think oak tree. So you have this massive tree whose trunk is made of individual cells. How does it accomplish that kind of size? Cellulose, the cell wall, supports the rest of the tree. None of us are going to gnaw on a toothpick, right? Not going to go out there and try and eat wood. Why? Because it's a lot of cellulose. You could eat the leaf. It wouldn't be very tasty, but it's not as much cellulose. It doesn't have a load to bear. There's nothing that's bearing down on top of it. Now, you should in your head have just thought, but I'm a multicellular organism, and the cells on the bottom of my feet have to support the load of all of the cells above it. And I don't have a cell wall. That was totally your next logical thought, right? That series of thoughts. You're like, but I'm multicellular. I don't have a cell wall. How is that possible? Yeah, I can tell. Looks like it was just a burning question. We instead have something else that helps us bear that load. We have a cytoskeleton. Cytoskeletons inside of cells are made out of smaller parts called microtubules and microfilaments. And I don't like the word skeleton because it makes you think it's really rigid, right? Makes you think it's like your skeleton. And your skeleton, if you were to take your skeleton, some of us know this all too well, if you take a hard part of your skeleton and bash it into something, not flexible, agreed? Like it just breaks. The cytoskeleton is flexible. Compare it more to cartilage. So now if you would like to figure out what cartilage does if you squish it, go ahead and squish your nose or your ear. And then unsquish it. Does it look the same as it did before? So it's rigid and provides structure, but it's not so hard that it would break under excessive load. Excessive load doesn't break it. Excessive load doesn't break it. Now, can you do something to break the cartilage in your nose and your ear?
Yes.
Yeah. If the load is too excessive, then it will break. Just like the cytoskeleton inside of any animal cell. How do you know it? Well, go ahead and take your arm and hit it against something really hard. And what happens?
My boy's about to be late.
Don't hit it that hard. Do not go home and be like, my science homework was to do this. Please don't. What happens?
It hurts.
You get a nice, beautiful blue welt, right? You get a bruise. All that happened there, you took cells and you exploded them. You exposed it to excessive load, and you broke them. The cell membrane exploded. The cytoskeleton collapsed on itself.
That's really bad.
Well,
Like,
bruises
way
are usually
worse than
unpleasant,
the
right?
stuff.
Well, imagine how it felt for that cell. That cell, that was it. It was done.
Gonzo.
Kind of cool.
Yeah.
Can you repeat what the cytoskeleton, like what it does?
It provides,
Or like what it is, I mean?
it's made out of microtubules and microfilaments, and it provides structure for cells.
How come some people like there's different ways?
Some people are just much, much better at breaking blood vessels than others. Usually it has to do with the amount of iron that they have in their blood. Though that doesn't, truthfully, that's not always true. You can have the correct amount of iron in your blood and still bruise really easily. You can pretty much just like poke me and I'll bruise. If you just walked up here, I would have a mark the size of this finger. I'm a bruiser.
What happens when like the dead cells, like what happens to them?
There's a couple of choices. Dead cells can be broken apart by some of the other organelles and recycled. Our body loves recycling. Or the flesh goes necrotic. If the flesh goes necrotic, think of that like the flesh-eating bacteria, like it just dies, like gangrene. So you got a couple choices. 1, recycle and repair, or 2, gangrene. Recycle and repair. Gangrene? Nobody wants gangrene.
No one's angry.
I have a question.
Ooh, you want gangrene?
No, I have a
Seems a little peculiar.
So if someone breaks their nose, like since it's cartilage, like what happens?
It will heal, but when cartilage heals, it usually heals in an uneven pattern, and it can't be set. So,
So that's like after you break it, it's all yours.
which is why sometimes if you break your nose, you have to have surgery. All they really do is allow your nose to heal, and then, do you really want to know this?
Yes.
Yeah.
Then they cut open the tip of your nose and then peel back the skin, and then take a little chisel and chisel off the extra cartilage that healed up, so it returns it back to its original shape. Usually they only do that if the part of your nose you broke was the septum, the thing that divides your nostrils in half. If you get what they call a deviated septum, so it turns instead of going straight, it restricts airflow, and that's when they choose to go in and take that chisel. It's like a tiny woodworker's chisel and a tiny little hammer.
I have a question.
Oh, yeah.
What if you only have one nostril?
How can you only have one?
You cut it, like you cut it. Can you do that?
You can't take the thing.
No, they wouldn't have because you require that in the middle of your nose to make a
No, he was.
It would literally collapse on itself.
No, like you could smell.
Bro, your nose would be like broken.
It would collapse, it would literally, your nose would collapse, like it would collapse and you would have it like a caved in.
Dr. Grant.
You know there are people born without noses, right? They have to have them like added.
We already done like that.
We're like Patrick when he got his nose surgery, and then we're like born
he's
with
done.
one big mouth.
I don't think I can tell. I was like, the last one, I was like,
It's just like
no,
a
not the last
The things that cross
So
our
they
mind.
were like,
I'm looking that up.
kind of with
Were you born without a nose?
No, just one big nostril.
The days were cool, so we weren't that far apart.
Just like
Oh.
no
I had
nose.
Dr. Grant.
So,
Oh, really? Dr. Grant's that
so the last couple things that we had to finish up before I can give you, oh, it's gonna be rough. You're not gonna have much time to do your homework, but that's okay.
Oh.
So is this cytoskeleton just for animals?
It's, yeah, predominantly we talk about in animal cell. 2 things required for cellular movement. One of them is called a flagellum, one is called a cilia. These are for cells that live in a liquid environment. So they only assist cells that are suspended in liquid. So often these are found in protists and certain animal cells. A flagellum is a whip-like structure, and a cell will usually have 1 or 2 of them, and they spin like a propeller to push the cell in one direction. It is not graceful. These are not cells that are going somewhere like in a defined pattern of motion, but rather they kind of like just go off at like all odd angles and then make random turns. It's a response to their environment, to escape one environment to enter another. Cilia, on the other hand, are very, very fine hair-like structures. And those very, very fine hair-like structures are intended to move a cell by waving back and forth in unison. So they wave back and forth in unison. Tomorrow you're in lab because, well, it seems kind of silly to talk about cells and not look at them. Yep.
Oh, what cells are the like flagellum?
What kinds of cells have flagella? A flagella would be on a variety of different protists, some bacteria, have flagella, so typically not animal cells. Well, some animal cells do. Like sperm have flagella, but other than that.
It's not like a chef.
Yeah. So, looking at this fine piece of equipment, I am going to not patronize you because I assume you have used one before. Accurate or inaccurate?
Accurate.
So you know that when you hold it with two hands, one on the arm and one on the base.
Yes.
Yes.
When you set it down on the tabletop, you do so gently with the arm facing your tummy.
Yes.
Arm and tummy. Those are the two things that meet. Not objectives to tummy, but arm to tummy. Eyepiece, that's what you look through. It's the last hour of the day, so technically I shouldn't worry about you leaving here with a headache for the rest of the day, except I know you're not going to go home and immediately go to bed, so I'm going to warn you. This is a guaranteed way to use a microscope and get a headache. You are forcing your orbicularis oculi, the muscle that surrounds your eye, to squish closed when you do that, and that will cause a nasty tension headache that no amount of Tylenol can assist you with. So do not do that. The best way to look through a microscope then, both eyes open. Now you're thinking, both eyes open. I can't keep both eyes open and have one eye look through something and have another eye look at something else. Deprive your eye of the
Teachers and
sensory
students, please
material
excuse this
it
late day
needs.
announcement, but I need to get some information out for all sophomores and teachers that are going on the Pledge Faith and Action Service Day tomorrow. So sophomores, please listen
Deprive
carefully.
your eye
Seventh
of
hour
the
teachers, if you
material
were
that
given a
needs
permission slip to
be
pass out to
also
anybody in your
white
seventh hour,
by covering
students,
one
please
eye
take
while
those permission
still
slips home
in
and bring them
timeout. So you
back
have to-
signed tomorrow morning. We had to reschedule
Your brain
a few students
automatically
because of
only
the
uses
weather.
one eye.
So if you got a new
Wow.
permission slip today, 7th hour, please return it tomorrow morning. All students and faculty are to report to the if you're on a service trip tomorrow, are to report to the cafeteria by 8 a.m. Students should be in jeans and a DC top. You must check in at 8 a.m. because we will be attending Mass at 8:30 here at DC.
You got this
If you are
last
going to
week. And you got it
Gleaners
last week.
tomorrow, you must be here at 7:15
Because
for 7:30 Mass.
Clearly,
And all students must bring a sack lunch. No lunch will be provided, so make sure that everyone does bring a sack lunch for their service day. And once again, 7th hour teachers, if you could pass out those permission slips. If you have any other questions, students, please stop by the office on your way out. Thank you.
The black stuff you can find on the videos. Yeah.
Sure.
Oh, the other one you that was on.
I
I watched the wrong video.
That was one big nose.
There was a video. Thank you. And then we had a walk. It was only 6.
okay, now that she's done, I'll keep talking about this then. A few simple rules. Low power objective is the short one. When you are on the short objective, you use the large knob for focus. Place the slide on the stage. Move the stage all the way up as high as it goes. And then focus down and away. So the stage and the objectives are moving farther apart. That guarantees that you don't make contact between the two. You are working with about $500 pieces of equipment. If you break them, I get cranky. So, number one way to break them, hit an objective to the stage. Easiest way to break a microscope, hands down every time. Once you switch to a higher objective, you use the tiny knob, the fine adjustment knob. If you want to see an object, it must be in focus on low power before you switch to high, or you will never see it. I say all these things and I do it quickly, and I know it's fast because, quite frankly, it means absolutely nothing until you're actually touching a microscope. Then you're using the microscope and you're like, oh, this rule suddenly makes sense. So there's not too much point in me, belaboring any of the microscope handling rules until you have a microscope in front of you. That said, some of you I am nervous about, and this is the first time in a few years I've had to say that to an honors crowd. I'm nervous about some of you using microscopes, so prove me wrong tomorrow.
Alex,
I will.
Thank you.